Welcome to Maths Video 31 on using algebra. The first section is on multiplying terms. If a number is multiplied by itself, it is that number squared. 3 times 3 equals 3 squared. 5 times 5 equals 5 squared. A times A equals A squared. Let's look at an example. First we'll start by multiplying the digits. 3 times 5 equals 15. Then I'll multiply the A's. A times A equals A squared. Then b times b squared would equal b cubed. Because in b squared I've got two b's multiplied together. I multiply a third b, that will give me b cubed. And then I only have one term with a c in it, and that's c squared. So my answer will remain c squared. And that is my answer. Section 2, dividing terms. A to the 5 divided by a to the 3. Well, we know that divide by sign is the same as a fraction line. So that's the same as a to the 5 over a to the 3. Well, a to the 5 is 5a's multiplied together, and a to the 3 is 3a's multiplied together. I can then cross-cancel or cancel down the terms. I can cancel an a from top and bottom. I can cancel a second a from top and bottom, and a third pair of a's, leaving two a's, a times a, which is a squared. Therefore, to divide by terms, all I need to do is take away the indices. 5 take away 3 is 2, so my indice is now 2. Let's look at it another way. Two of the same numbers cancel each other out. We'd expect that. A squared letter divided by the letter is just a letter. What do I mean by that? Well, if I have anything squared and I divide by the base number, I get that number. So 4 squared divided by 4 equals 4. 4 times 4 is 16. Divided by 4 equals 4. It's just using an inverse operation. To square something, I'm dividing by itself. So if I divide by that number, I'll bring it back to the original number. Therefore, a squared divided by a will equal a. Let's look at an example. I will start by dividing the numbers. 6 divided by 2 is 3. Y squared divided by y equals y, because the square divided by the base letter will equal that letter. And then z divided by z, any number divided by itself will give me 1. So that will give me 3y. Balancing an equation. This is central to algebra, and you'll use this constantly between now and when you finish learning maths, whether that's A-level, beyond, or whenever. This is something that's really useful to get to know and be able to do well. When we're balancing an equation, we can think of an equation as two sides with an equal sign in the middle. And both sides must be equal to each other. They must have the same value. If the two sides have the same value, if I add the same thing, they'll still have the same value. So if I add 3 to the left, as long as I do the same to the right, it will still have the same value. If I take something away, as long as I take the same thing away from both sides, they will still have the same value. If I multiply the left by 2, then as long as I multiply the right by 2, they will still have the same value. You can think about it in terms of a pile of oranges. If I've got a pile of oranges, if I add 3 oranges to both sides, the scales will still be equal. I still have the same number on each side. If I double the number, as long as I double the numbers on both sides, they'll still be equal. Let's look at an example. 5x plus 3 equals 48. Well, the first thing I want to do is I want to get the term with the letter on its own. So I want to get rid of the plus 3. Well, how do I get rid of plus 3? Well, I take it away. But whatever I do to the left side, to the right, I do exactly the same. So I'm going to take 3 from both sides. And I end up with 5x equals 45. But I don't want 5x, I want just x. Now, we know that 5x means 5 times x. So, to get rid of the 5, I need to divide by 5. But if what I do to one side, to the other side, I need to do exactly the same. So I'm going to divide both sides by 5. And that gives me x equals 9. Fourth section, creating formulae. First, we'll look at working at the nth term. So if we have a series of numbers, we work out the difference between each term, and then that becomes our multiplier, and we add or subtract to make it correct for the first term of the sequence. Let's look at an example. So in this example, I'm going to add 2 each time. So my sequence is 5, 7, 9, 11, and 13. So to go from one term to the next, I'm adding 2. Now if I can repeatedly add 2, that's the same as multiplication. So adding 2 4 times is the same as 2 times 4. So whatever you're repeatedly adding, that becomes your multiplier, because you're multiplying it the same number of times as the number of terms there are. So in this case, my multiplier is 2, and so I have 2 times n. Then I look at my first term, which is 5, and I put that into my 2 times n. So n equals 1 for my first term. 2 times 1 equals 2. How do I go from 2 to 5? I add 3. So my equation is 2n plus 3. So now if I want to know the 100th term in this equation, I go 2 times 100 is 200 plus 3 is 203. And my 100th term is 203. It's much quicker than adding 2 100 times. Algebra can also be the easiest way to solve many word problems. Replace items you want to work out with a letter, normally a related letter, but not one that can be mistaken for a number, and then solve. Let's look at several examples. Firstly, Tori has 36 apples and oranges in a fruit bowl. She has 3 times as many apples as oranges. How many oranges does she have? I find it always useful to use the letter with the object that has the least number. So we've got less oranges. So I'm going to look at oranges. And let the number of oranges be F. I will never use the letter O because it looks too much like a 0 and it looks too confusing. Even if you can tell it apart, your examiner will struggle. So always avoid O. So the number of oranges be F. Well, we know she's got 3 times as many apples as oranges. So the number of apples will be 3F. Now I know the total number of apples and oranges is 36. So if the number of oranges is F and I'm adding that to the number of apples, which is 3F, that will give me 36. I can then solve the equation using balancing equations I did in the last section. Well, F plus 3F is 4F. 4F equals 36. So how do I find F? Well, 4F is 4 times F, so I'll divide by 4. And 36 divided by 4 is 9. Whatever I do to one side of the equation, to the other side of the equation, I do exactly the same. Therefore, she has 9 oranges. It doesn't ask how many apples she has, but I know apples is 3 times F. So that would be 3 times 9, so she should have 27 apples, giving me a total of 36 fruit. Another example, if a number is multiplied by 6 and 5 is added, the answer is 47. What was the number? To do this, I can simply write the sum. So I've got a number multiplied by 6, so that's 6n, and I'm adding 5. So that's 6n plus 5, and the answer, or it equals to, 47. I can then solve this in the same way as I did in the last section. I want the term with the letter on its own, so I need to get rid of the plus 5. How to get rid of plus 5? Take 5. So I need to take 5 from both the left and the right, giving me 6n equals 42. I then want to get just n, so I need to divide by 6. But whatever I do to one side, I do the other side. So I'm going to divide both sides by 6, which gives me n equals 7. Let's look at another example. Akshane has a younger sister, Brianna. Akshane is 4 years older than Brianna. The sum of their ages is 12. How old is Brianna? Well, let B equal Brianna's age. Akshane is 4 years older than Brianna, so Akshane's age will be B plus 4. And I know the sum of their ages is 12. So Brianna's age B plus Akshane's age B plus 4 must equal 12. Therefore, 2B plus 4 equals 12. I'm going to take 4 from both sides, giving me 2B equals 8. Well, 2 times B equals 8, 2 times 4 equals 8. So Brianna is 4. Friday after school, Shadrach starts reading a book. On Saturday, Shadrach reads 25 more pages than he read on Friday. He reads 105 pages altogether. How many pages did he read on Saturday? I'm going to let the number of pages he read on Friday be X. And we're told that he read 25 more pages on Saturday. So Saturday, he read 25 plus X. He read a total over the 2 days of 105. So his X on Friday plus his X plus 25 on Saturday equals 105. Therefore, 2X plus 25 equals 105. Well, to get just 2X on its own, I need to take 25. But if I take 25 from one side to the other side, I must do exactly the same. And that gives me 2X equals 80. Or 2 times X equals 80. 2 times 40 equals 80. So X equals 40. Now, the number of pages on Saturday, if we look back to our equations, is 25 plus X. That is 25 plus 40, because I know that X equals 40, and therefore he read 65 pages on Saturday. Thank you very much for watching these videos. I hope you found them very useful. And that comes to the last of this series of maths videos. Bye.